Hello friends, today I am going to create a video over how to download satellite images from different portals. So for this, the motivation behind this creating this video is the course that I gone through in my last semester. Actually, I opted for this remote sensing course, and before this course, I just heard about this satellite images and what is grid and raster and vector dataset. But now I have clear idea what is this satellite images, how they can be downloaded, and how we can make use of it by making different composites, and how we can extract the data features from the images, right? So let us start. I will be making a series of videos. This is the first video basically. So I'm simply searching satellite image download portal. So what I got is this geography link, 15 satellite image data sources. So this website lists multiple sources from where we can download the satellite images, right? So first one is US Art Explorer. This is the portal that I used during my class. I used to download Landsat 8, 9 images and work over that, right? So basically Landsat images comes in 30-meter resolution from band 1 to 7. For thermal band, panchromatic band is a little finer, that is around 12 meter, I guess. Let us see. So Landsat 7 has 8 spectral band ranging from 15 to 60 meter. No, yes, here we will get the information. So it has 30 meter visible near infrared and short wave infrared. Thermal bands are 100 meter, and this panchromatic is 15 meter. So this is the finest possible resolution in Landsat, right? Now let us move toward uh, the image portal. So there are multiple portals. There are Sentinel images, Sentinel Copernicus browser, from where we can get download the Sentinel images. But in this video, I will only be covering this USGS Art Explorer. Further explorers will be covered in upcoming videos, right? And similarly, we have NASA Art Data Set Search, and there are some more, but it does not list Bonidi portal. I guess Indians portal is not listed here. So in upcoming video, I will be adding in ISRO's Bhuvan and Bhunidhi portal, and we will download images from there also, right? So this is USGS Art Explorer, and you can simply search Art Explorer on Google, right? So the first website shown on the search index will be our Art Explorer website. So as you can see, this is United States government website. This means this website is owned by US government, US Department of Interior, right? So this is the viewport. Basically, if you want to download the image from this portal, you will need to sign up. So without signing up or signing in, the portal looks like this. You just need to click on login and enter your credentials. Otherwise, if you have not, then just go for create new account and make one. I am just logging in to my account. So after logging in, the viewport is quite interactive. Like at the right, we have a global map from which we can choose the region of interest. So I am choosing my home district, Nalanda, right? So in order to choose, we can just tap and make a quadrilateral or make a polygon. It is up to us, right? Otherwise, this is one option. Otherwise, we it provides the option to choose a point and give a radius. Like I'm giving 50 kilometers radius. So 50 kilometer cover the entire Nalanda district. And if we give 30 kilometers, so 30 kilometer also covers the entire Nalanda district. So this is the way we can select the images. And there are some other methods like for American states, you can just choose the shape files that is given in the list. Like you can see these are the US states, but I am choosing a study region in India. That is why I'm using the tab feature, basically the polygon feature. So just tap it and select, right? Here we get options to give the date time interval. So I am just giving a random date time interval that is from October to October 2nd October to 16th December, say today is 17th December, right? And we have option to restrict the cloud cover. I'm restricting the cloud cover to 10% because if cloud cover is more than 10%, then it create difficulty in analyzing the image, right? Now click on dataset. So we have multiple dataset here. So here we will select a Landsat dataset. We can also explore some other like vegetation monitoring. This is the imagery based on this indices. There are some images using NDVI and there are other indices are listed, right? And there we can see ISRO resource set dataset. It means USGS share dataset data with ISRO. And ISRO data is listed here. Anyway, we are interested in Landsat images, so we will continue with Landsat collection to level 2. Level 2 high because it comes with several level of pre-processing like atmospheric correction. And if we talk about level 1, so level 1 images are the images that are raw images that has no processing with it. After this, there comes analysis ready data. This comes with certain enhanced level of processing. Then level 3 is also science product. This has additional level of corrections as compared to level 2, right? Level 2 is also science product. So we will continue with this Landsat 89 poly and TIRS. We got some notice, click OK and proceed. So I am going to search the results. It will show all the images that has been captured in that interval that we have provided in the first step, right? So these are the images. Also, friends, here we get one option like we can manually change the number of results to be viewed in the list. So it is 10. Therefore, in results, we are seeing that 10 images only. See, now uh, we get certain buttons here. So first button is to show footprint, meaning it just locate the region where the image is actually captured in which grid and tiles. So before going to this, just look at this row and path. So what basically row and path defects is, I'm going to explain you using Paint, right? Let us take any globe image for explaining purpose only. So I have copy pasted the image. Now For instance, suppose okay, suppose a satellite pass through this way, right? And it comes back in some other path again. It goes like this, and it comes again like this, and it crosses the globe with in different times, and again after few days or say weeks, it again passes through the uh, same path, right? Suppose these are the paths. So in the case of Landsat, the temporal resolution is 16 days, meaning if satellite has passed through this point on day t is equal to 0, then it will again pass on the same point with from that location at t is equal to t plus 16 days, right? So this 16 is the temporal resolution of Landsat. So now let us look at the path. So the okay. So suppose this is the path that image covered in one day, and this is the path that image is covered in some other day, and this be some other day. So when it passes, it take 30 cross 30 image, and so the tiles are 30 cross 30 meters, right? So there will be certain grids like this, and these grids are known as rows, right? So this one is path, and these are these grids are called as rows, right? So for one path there are multiple rows, and these rows corresponds to a tile. Basically these make a tile like this. This is what we have seen here in the portal itself. This is a tile. And now we have to wisely choose which tile covers our area. So we have already seen that this one covers almost of our region, but not this one. So if there is cloud cover, then we will look for the same tile in another date, right? So if we want to see the cloud cover thing, we will click on this button, just hide this. So this will just overlay. See, at the end there is cloud cover, but in our district region there is very less or no cloud cover. So this is good to go. And if we want to exclude some region from our study region, then we can use this red cross button, right? And if we want to view the metadata of the file, metadata basically contains the information about the image, what is the name, when it is acquired, and row path, etc. With this you can see that uh, the view with the images taken is Nadir view. Nadir view is basically the top view, right? So there are multiple information provided here. And basically, when we download the image, we get MTL file. It consists of all the metadata, right? So let us proceed with this image. So if we want to download the image, Either we can add this to bulk, and in bulk meaning we can download multiple images by adding into cart. Otherwise, we can simply download by clicking here. We have clicked the option. It gives reflectance bands and temperature bands. These are provided separately, but it is not advisable to download them separately. Rather, you can use all these options to download them. Rather, you can use this button to download the entire bundle at once. So in bundle, they provide all the reflectance bands, like 1 to 7 is there, aerosol band is there, band 11, band 10 is also there. So this is surface temperature band. This we will see in upcoming videos on this band, and band 11 is also used to calculate the temperature, right? So just click on this button, or if you want to individually download a file, you can just click over here. So this is the MTL file. These are the metadata file that we will get with the package. I'm clicking on download. It takes some time, but it downloads. As we can see, our image downloading is complete. So we will move to the file explorer to explore this file. Yes, this is the file. So this is 860 MBs. Its name start with LC09. We will see the nomenclature part. First, let us extract the files here. Okay. So this is the structure of files. Basically, they are provided even ANG file. ANG file basically contain all the information regarding the coordinates and all the parameters that is used for the grids. Like for coefficient for particular bands, see, we have the coefficient for band 5, similarly for band 6. You can explore it more. Then we have JSON file and text file. These both are MTL files, metadata files. So let us open this text file. It contains all the information about the file contained inside the zip folder and about what it is, like L2SP, it is level 2 science product. So it contains all the information about the image basically. So if we want to explore all the bands at once, then we can just provide this MTL metadata file as input to the software like NV and ArcGIS desktop, and after taking it as input, it will just open all the file in the data explorer. Like here we have file B1, B2, B3. These are different band files. So different band file correspond to a range of wavelength in the spectrum. So we have till B7, and then we have this aerosol band and B10. So these are of our use, B1 to B7, and this B10. B10 is a temperature band, temperature surface temperature band, right? And there are some more that they can be explored, but the mainly used band are these B1 to 7, and then B10 or B11 in some cases, right? So this is the image file. You can have a look. The image file has format ending with .tif. So what is the difference between TIF and the images that we take from cameras and these satellite images? So the difference is basically in camera images we do not have any georeference data basically with grids. There is no latitude, longitude associated or anything, just the DN number, digital number is associated, like how much brighter is it and how much darker is it, and on the basis of that we identify someone face or some features, right? But in satellite images it becomes very necessary to provide the georeference, that is, to each grid there should be an association to some latitude longitude so that it can correspond to the region from where the image is taken. So someone if want to explore the image, they can just click the image on the globe and they can see how it looked like when the image was taken, right? So we will see the uh, processes in upcoming videos, but the thing is, this TIF means tagged image format. This format is used for the satellite images in general, right? There are some more like JP2 images that are provided by Sentinel Copernicus browser, but TIFF is mostly used. So this is the image, and now let us uh, look about this nomenclature. So for this nomenclature, just search Landsat nomenclature, because nomenclature clears so many things. You can just uh, tell so many things about an image just by seeing its name, right? This is how it works. So for a Landsat image, the name is like this. So first L means Landsat, X implies sensor. So in our case, the sensor is both TIRS and OLI. OLI means operational land imager, and I do not remember the abbreviation of TIRS. So TIRS is thermal infrared sensor and operational land imager. So these sensors have combinedly taken the images. SS meaning satellite. So in our case, it is LC09 meaning Landsat 9. If it is 7, then Landsat 7, or 8, Landsat 8. And LLL means processing level. In our case, it is L2SP meaning level 2 science product. I have already discussed that level 2 and level 3 are uh, comes with some level of pre-processing, whereas level 1 doesn't have any processing in it. And the path and row portion we have also already discussed, so we can predict about the path and row from the file name, like it has 141 path, no, 141 path and row number 42. So this tile corresponds to 141 and 42. MMDD is the acquisition date time, and this smaller, so smaller is the processing time, right? So in our case, the image is taken on 10 December 2024, whereas the processing took place on 11th December 2024, just one day after the image has been captured. So this information we can get from the image name. Then we have collection numbers. Collection number is the set of images. So in our case, it is 02 meaning collection 2, and then TX meaning the category, meaning real time if the image is taken at the time and it is being shared at the same time, then it becomes real time. And then tier 1 and tier 2 are the classes that comes with different temporal resolution. So in our case, it is tier 1 image. So these are the information we can get from our Landsat image name. So guys, please subscribe the channel if you want to get more videos like this. In upcoming videos, I will be uploading videos using some other portals, and we will learn to download the images from other portals also. And after that, we will go through different softwares like NV. In NV, we can do image processing, so we will be covering NV, and Then we will make use of ArcGIS Pro. No, not Pro, ArcGIS Desktop, and we will try to explore these images on those softwares. And in the upcoming video, in next video to this video, I will be exploring the Copernicus Sentinel portal, and then is India's ISRO Bhuvan and Vonidi portal. Right. So thank you. Just keep watching the video and subscribe. Thank you.